Welcome. Today we're going to be reviewing digital marketing attribution. So, in the marketing funnel, you have the top of the funnel activities where you're trying to drive awareness. Then you have middle of the funnel where you're trying to drive consideration, and then you have the conversion stage where you're at the bottom of the funnel. And so some marketeers will create some acronyms like TOFU, which stands for top of funnel, not tofu the food. This stage is going to be middle of the funnel, and this stage over here going to be bottom of the funnel. Now, why this? Let me just make sure that you guys can see. There we go. This is your quintessential marketing funnel. You have the top of the funnel where most of your activities are going to be to drive awareness towards your brand. Then you have middle of the funnel activities where your aim is to drive consideration. So people already know a bit of you about your brand. They need that extra push to consider you. And the bottom of the funnel is the conversion stage. And the loyalty is also bottom of the funnel, but in here you're in CRM activities. So since we're going to be discussing more on the acquisition side of things, not on the engagement and the CRM side of things, we're going to leave that for a later video. The main goal, or one of the main goals of a marketeer, is to drive conversion. And to be able to do that to the best of their ability, they need to measure the value of each channel. And they need to measure how each channel performs so that they understand where should they put their budget. And in here, this is where there's a lot of different ideas and a lot of different opinions and a lot of different techniques. We're going to be discussing multi-touch attribution, or also known as data-driven attribution. Now, to understand multi-touch attribution, we need to understand what is rule-based attribution or heuristics-based attribution. So let's have a little bit of a look. This is my book, Data Analytics for Marketing. I'm going to be reading off of it since I already wrote about this. But at the moment, I want to focus here on a journey. Following that funnel, you can be traveling through different channels. So you can see a display ad. You can not click on it, and that's going to be an issue on some models, and we'll get there. But let's see, you could see a display ad on a website. Then you could see Facebook ads on your Facebook feeds. Then you would search you would go on Google and you would search the product, and then you would see a paid search ad, and you would click on that ad and you would convert. So if we draw this, you can have multiple paths. So let's take a simple one and let's do some changes here to understand what the hell we're talking about. So let's imagine a situation where we saw a display banner and this gave us awareness, and then we saw Facebook ads and this helped us in the consideration phase, and then we wanted that product and we searched on paid search and we saw a Google ad. And after this, we actually converted. Now we have the actual conversion. So we saw a display banner. So this is top of funnel. We then saw a Facebook ad. So now we're in the middle of the funnel. And now you're seeing the paid search ad here, and you actually convert here. Now, in the digital world, I can actually track people. So I know that if you click a link on a specific ad and you land on my web page, if I provide that link with so-called UTM parameters, my analytics software can then say someone clicked this display banner, or someone clicked this Facebook ad, or someone clicked this paid search ad. And most common analytical packages are Google Analytics or Adobe Analytics, or there are several others. But for argument's sake, let's keep them to Google and Adobe because those are most of the market share. So that means I can see number of clicks and visits from each channel. Then the question is if I can track the touch points, and there's going to be an issue on the accuracy side of things, but later on that on the video. But if I can track each touch point and we can understand each channel as a touch point, then the question is, how do I assign the value to each channel? If this conversion gave me $100 worth of revenue, which one of these 3 channels should be given the credit? And this is where rule-based attribution models or heuristics-based attribution models come in. The reason why it's called rules-based is there's a fixed rule. This is in opposition to data-driven models, where there's an algorithm, a machine learning algorithm, doing the heavy lifting. To understand this, each chart has 5 touch points. If the bar is yellow, there's no credit given to that touch point. If the bar is blue, there's credit given to that touch point. If there's multiple blue bars, the size of the bar illustrates roughly the percentage of credits. And the sum of blue needs to be 100%. So the most commonly used rules-based attribution model is the so-called last click or last touch attribution model. And it used to be the default on many packages. It's no longer the default on many packages. But it essentially says, I don't care about whatever happened in the past, what touch points you pass through. I only care about the last conversion point. In our example, I only care about the paid search ad. I only care about the channel that drove the actual conversion. I don't care about anything else. There's a slight variant to this model, which is the last non-direct touch attribution model. And the difference is the last channel a direct channel or not. And what do I mean by direct channel? Let's have a look at another example. But here, instead of we having the conversion, here we saw the paid search ads, but we don't convert on the paid search ad. We saw wherever we wanted. We made the decision not to buy, but then a day after, 7 days after, let's not worry about conversion windows at the moment. But the next touch point is I went direct to that website. So by now I know the website, Nike.com, for instance. So I typed it Nike.com on my browser. I went direct to that website and I purchased. The difference between these 2 models is essentially that in last click attribution, direct gets the credit because it's actually the last interaction. You went straight to the website. Bookmarks are also direct traffic. But last non-direct touch attribution tries to reattribute all of the direct traffic. So you go back 1 touch point, the last non-direct, and you assign the credit there. So in last click, if you take this example, in last click it's direct that gets full credit. In last non-direct click, it is paid search that gets the full credit. Now this will give an advantage to bottom of the funnel channels. Channels that are geared towards making you act. Paid search is the quintessential performance channel. Affiliates is also a performance channel. These are channels where the target audience has a high intent to buy or a high intent to act. If I'm searching for something, that means I have an intention, an active intention that made me search for something. I'm searching for hotels in Spain. That means if I'm shown an ad, I'll probably click on it because I'm looking to book one. Awareness channels in last click model basically get no credit. Activities like brand awareness, out of home, TV advertising, even if it's digital TV, which you can track these days, you don't get credit. Programmatic display advertisement also doesn't get credit in this model. paid social, if you are running consideration type campaign on paid social, it doesn't get credit. So if you're not careful and you don't understand the problems with this model, and you're trying to calculate return on investment, then the solution is simple. Put all of your money on paid search, ignore every other channel, and you should be golden. Now, you're not. Paid search needs brand awareness, and we can go into this at a later date, but essentially, this is the problem with last click. Now, last click used to be the default on most packages, on Google Analytics, on Adobe Analytics. The opposite to last touch is first touch. So here, instead of giving 100% of the credit to the last touch point or the last non-direct touch point, you give 100% of the credit to the first touch point. So in this example here, the difference between last touch and first touch is that in last touch, paid search gets full credit. In first touch, it's the display banner that gets full credit. So this is the exact opposite. While last click benefits the bottom of the funnel 100%, and it completely obscures the rest of the funnel, first click models will tend to give high privilege to, or 100% privilege to, the top of the funnel activities. You might say, okay, then I'm gonna give equal share to all channels. Every touch point, I'm gonna give it equal share. So if I have 3 touch points like I have here, then a third of the value is going to be for the display banner, a third of the value is going to be for the Facebook ad, and a third of the value is going to be for the paid search ads. Why a third? Because I have 3 options. If I had 4 options, then it will be 25% for each touch point, and 25%. If I have 10 touch points, then each one of them is going to get 10%. Now, the advantage, the obvious advantage, and this is called the linear attribution model. The obvious advantage is you're going to have visibility over the entire funnel. The disadvantage, the drawback, is you're going to undervalue key touch points while overvaluing less key touch points. It might be that in your journey, the bottom of the funnel is more important than the top of the funnel, or vice versa. In here, you're just saying, well, I don't care, I'm just going to give them equal value to all of them. Here, you're trying to understand the full path to conversion, but you need to be careful that you shouldn't put too much emphasis on each individual share. Then there's the next alternative, which is the understanding that we might want to give more emphasis to the last touch, i.e. the most recent touch, but we also want to give some credit to the upper funnel parts and the middle of the funnel. And the way I'm going to do this is the longer it has passed since that interaction, the less the share. So if you saw a display banner a month ago and you converted on paid search yesterday, I'm going to overweight paid search because it's more recent, but I'm going to give some credit to the display advertisement a month ago. And you can specify this time decay function. And finally, there's position-based attribution. Position-based attribution is an attempt to be... It's an attempt to get the advantages of first click and last click and linear. So you're trying to give some weight to the bottom of the funnel. You're trying to give some weight to the top of the funnel and not miss the middle. But what you're saying is the awareness part is really important to me. The conversion part is really important to me. Everything in the middle is less important. So usually, for instance, what you do is you give 40% to the last click, the last interaction, you give 40% to the first interaction, and you split 20% amongst the remaining ones. Again, these are fixed. And again, I know that these charts show you 5 interactions, my examples, one shows 3, one shows 4. There's no set number. You can have 10 different interactions, which means if you're in winner attribution, then you're giving 10% each. If you're in last click or last touch attribution, you're giving 100% to the 10th, ignoring all of the previous 9. There's a final one, which is not shown in the chart here, which is custom. And custom used to be, I believe, good old days of Google Analytics, where you, the marketer, or you, the analyst, define the weights you want. So you say, I want the last touch to be 50%. I want the previous touch to be 20%. I want everything else to be 10. Now, this is a lot of gut feeling. This is a lot of I think moments, I feel like. And it's not very data driven, let's be honest. So, in the last few years, some attempts have been done to create an algorithmic approach to this. And this is where multi-touch attribution or data-driven attribution comes in. Can we do better than rules-based? And the answer is yes, we can. Data-driven attribution is essentially an algorithmic way to assign value to the touch points. But instead of being a hard-coded rule, like 100% for the last touch or 20% for all the middle touches, it's based on a machine learning approach. Let's have a look at that driven attribution. There's two main algorithms used to do data-driven attribution. One of them is called Shapley value attribution, and the other is Markov chain attribution. Shapley value attribution. Shapley value attribution is the algorithm behind the data-driven attribution of Google Analytics, and simplification of Shapley value attribution by Google because of some considerations, which is called fractribution. The Shapley value attribution is a computationally intensive algorithm. So Google came up with a simplification called fractribution. They even have a package for it. And on the other side, you have Markov chain attribution. And Markov chain attribution is simply the use of Markov chains and their transition probabilities to calculate the channel shares. So in a Markov chain, you're going to have states, and those states are going to be, in our case, our channels. So you have channel X, channel Y, channel Z. So in a Markov chain attribution, you have a Markov chain where you have states, which are the channels or the conversion, and you're going to have probabilities of transitioning through these states. So you can go from channel X to Y with probability 0.5, for instance. So every state has a probability of either going to the next state or going to itself. So basically, in Markov chain attribution, you will try and model things as a Markov chain. A Markov chain is basically a chain of states and transition probabilities. In our case, each state is going to be either a channel or you either convert or not convert. And the transition probabilities are basically going to be what's the probability in the data of a user going from channel X to channel Y. There's also, in a Markov chain, you also have the probability of staying inside the same state, which is what these self-referencing arrows mean. Essentially, once you have this, you can then calculate the probability of going through a specific path and ending as a conversion. How do you go from here to assigning credit to a channel? You essentially want to understand its removal effects. Once you calculate the transition matrix, which gives us a probability of transitioning through one state to the other through all of the states, we then calculate the removal effects. And the removal effects, it gives us the probability of transitioning from one state to the other with the removal of a state that we're interested in. And in our case, what we're essentially doing is understanding the effect of removing a channel from the transition matrix. So if we go back here, we have this directed graph. You'll then remove one of these channels and recalculate the conversion rate without that channel. And that will give you the value of that channel. So the idea here is fairly simple. If I have 3 channels and I remove one of them and my conversions drop by 50%, that means that channel is worth 50%. That's essentially it. The way we're trying to generate the probabilities is algorithmically. So this is where the Markov chain model comes in. So Markov chain attribution is a little bit computationally intensive because you need to calculate the transition matrix and then you need to iterate through it. And let me know in the comment section below if you want me to go into further detail of Markov chain attribution, but essentially this is what you're doing. Alternatively, you can have Shapley value. Now, Shapley value attribution, you're trying to do the same thing as Markov chain attribution, but with a different algorithm. So Shapley value attribution comes from Shapley values, and Shapley values are a concept from game theory. It was authored by an economist named Lloyd Shapley. And basically, it was a way of, in a cooperative game, calculate the contribution of each player. The example I give in the book is if we consider a simplified example of divvying the payout from a game with different players. So there's a group of 4 friends, and I named them Alice, Bob, Carol, and David. And they decide to work together on a side project that yields a payout of $100. And the problem becomes, how do you divide the credit? How do you divide the payout in such a way that it's fair? And it will reflect the contribution from each player. And you can think of this as a little bit of an iterative process where, for instance, to keep the example manageable as I do in the book, you can consider them in pairs. Alone, nobody can do anything. Alice and Bob, if they work together, can generate $30. Alice and Carol working together can generate 40, and so forth. And all 4 can generate 100. The way to think about Shapley values is, given this list of pairwise contributions, we are gonna create coalitions, which is basically all of the potential combinations of value. And then, same way as in Markov chain, we are gonna remove one of them and calculate the removal effect. Now, the mathematics of this is a little bit more complicated. So is the Python code. Tell me in the comment section below if you want me to do a deeper video on this. But essentially, you're trying to see all of the combinations, all of the coalitions, check the removal effects, and from there see the value. So in a sense, Shapley value attribution is calculating the channel value the same way as Markov chain attribution, i.e. by calculating the removal effect. But the difference is how to calculate the value itself. So in Markov chain attribution, you're essentially calculating the transition matrix and all the probabilities, and then you're removing one of these states or channels and see what happens to the conversions. And in Shapley value attribution, you're calculating all of the potential coalitions to generate the value, where each coalition member will be a channel, and see if removing a member from one coalition, what's the effect on the final conversions. Both of them are essentially doing the same thing. but in different ways. Now, Shapley values are computationally intensive, and the issue is that to calculate the coalitions, you're basically calculating permutations over all of your channels, and this means exponential growth. Because if you have n channels, the number of permutations is going to be 2 elevated to the power of n, which is going to be a really large number really fast. The second aspect is it doesn't take into account the order of the touch points, i.e., it doesn't take into account which part of the funnel did you go through, in which order, by time. And if you want to take that into account, then again, you have another problem, because now the rate of permutations is going to grow at the rate of n factorial. To make things simpler, Google developed a simplification called fractional attribution or fractribution. And essentially, in fractribution, you need to understand path transforms, i.e. path to conversion transforms. And some path to conversions are similar to others. Maybe it's you have only one touch point that is removed, or you have touch points that are duplicated. So, for example, if you take figure 11.6, you can convert this path to just being direct paid search, generic and paid search brand. This is one way of doing it, and there are several. And in the book, there's a little bit of a description on the several ways of doing this. But essentially, the path transforms, you can either do unique, where you treat all of the events in a path as unique, which basically means you don't remove anything, you don't add anything. This works best if your look-back length is short, you have low volume, and you do very specific marketing, or don't do a lot of retargeting. Then you have exposure, where you essentially collapse repeat events that are immediately in sequence. So if in this example, if you have touch point A, then touch point A again, then BCB, you collapse the first two A's because they are in sequence. But you don't collapse the B's because you have C in the middle, so they are not immediately in sequence. It's a balance between first and unique. What is first? First, you take only the first occurrence of a touch point. So in this example, you have A, B, C, B. You take the first A, you take the first B, and C, and it becomes ABC. Then you have frequency, where you basically you count the events from their first occurrence. So you have AA, B, C, B, then you group them as A, 2 counts, B, 2 counts, and C. This is useful where you have retargeting, a lot of retargeting, or you have a lot of follow-ups. So there's going to be a lot of round trips between touch points. And then recency, where you look at where the event occurred in the timeline before. So where's the touch point before the conversion? And then you do the following. You treat the same events differently if they occur in different time buckets, and you collapse them if they occur in the same time buckets. If you look at longer, if you have a longer look back period, greater than 30 days, or a tiered marketing strategy, this works. So essentially, in the example, you can see that touch points B and C occur at the same time bucket, i.e. a day ago. So they get the B's get. You notice that the B's occur in the same time bucket, i.e. a day ago. So you collapse them. The A's, however, you don't, because the first A was 15 to 30 days ago, and the second A is 5 to 7 days ago. And the fractribution algorithm is a simplified form of the Shapley value algorithm. So you start with the baseline path, which is your path at which you're going to compare everything. And then you define what's called the leave one out counterfactuals. I.e., again, we're going to be estimating removal effects. You can see a pattern here. Basically, we're taking one channel out, so this is the alternative potential path without one of the channels, and you do this with all of the channels, and then you calculate the conversion probability for each counterfactual, because you have all of the combinations, so you have all of the correlations, but you have less of them because you're doing path transformation. So instead of growing exponentially, you're trying to reduce the size of n being the number of channels, to make it easier to calculate. So you calculate the conversion probability for each counterfactual, where the conversion probability is simply the total conversions divided for that counterfactual divided by the total conversions plus the total non-conversions. And then you calculate the marginal contribution. And the marginal contribution is basically the difference between the baseline full path and that counterfactual path. So you then have the marginal contribution of, for instance, direct, and marginal contribution of paid search brand and paid search generic. And once you have these, you just normalize them. And what normalization means is essentially you are making sure that the sum of all of the marginal contributions sums to 1. So it's basically the marginal contribution divided by the sum of all the marginal contributions. This will make... And then you just repeat this for all of the paths. And there's a Python implementation, and let me know down in the comments if you want a further video on that. Now, these aren't the only way of doing data-driven attribution. You can do regression-based attribution, for instance, where you try and use a linear regression to calculate your attribution amongst digital channels. And there's specific ML, or there's custom-made ML methods some companies or some vendors use, but fundamentally the most common ones are these two. Now, what's the problem with marketing attribution? Or not the problem with marketing attribution, what's the problem with data-driven attribution? You need granular data, i.e. you ideally need to track your users through every touch point. Now, before we go into privacy issues and GDPR and all of that, we need to contend with the fact that not all channels are click-based. What do I mean by that? All of this data comes from an analytics software. It comes from either Google Analytics or Adobe Analytics or alternatives. It doesn't matter. But essentially, you need to understand that even with server-side setup, client-side setup, and we can go through them in a later video, but even on those setups, you will only record the touch point if a user lands on your website, because the data collection is happening at your website. That means that for you to understand a marketing touch point, you need to understand a user saw that advertisement and he clicked on that advertisement, which means he landed on your website. This is a potential problem because you are going to have certain activities, marketing activities, that are not driving clicks, particularly top of funnel activities. A good joke I like to make is nobody clicks a banner unless they misclicked. That is not the point of banner advertisement. That's not the point of display advertisement or programmatic advertisement. That type of advertisement is geared towards the awareness piece of the funnel. It's top of funnel. The point is to drive views. If people view your brand, they will become aware of your brand. So people won't click those ads. People will not land on your website. So your analytical software will not pick it up. A similar problem is all of the so-called above-the-line advertisement and out-of-home. So if you're doing sponsorship, you can't track the clicks. People aren't landing on your website. If you're doing out-of-home advertisement or ads in the tube, unless you're trying for people to convert and you have a QR code or a coupon code, people will not be visiting your website. And if they are, you don't know, or at least not immediately, if they have converted for seeing that out of home ad. So everything that is offline is not measured. Anything that doesn't drive clicks is not measured, which means even in the data-driven attribution world, you are only getting an incomplete picture. And this is often overlooked by marketing professionals, even in the digital marketing world. If you cannot collect the view data, i.e., people that have viewed your specific ads but have not clicked on it, this attribution type will be incomplete, which means it's going to be slightly biased. The second problem of data-driven attribution, or digital attribution in general, but data-driven in particular, is that you need really granular data. You need to track people through every touch point with a unique ID. You need what's called clickstream data. And there's been a movement, a backlash in the past few years of consumers becoming privacy aware. Either regulation like GDPR, forcing vendors to become more restrictive on what data they allow out, or consumers just being aware of that and choosing to use ad blockers, for instance, or tracking blockers, or even hardware and software vendors like most prominently Apple actively blocking tracking. So in the Apple world, iOS in the iPhone case, or the Safari browser in the Mac OS case, they have something called intelligent tracking protection, which is incredibly robust to tracking. So ever since iOS 14 and the corresponding Safari version, the tracking capabilities that marketeers have in Apple devices has been greatly reduced to the point where you mostly can't see those conversions. They block pixels, they block tracking software, and they are really good at it. There's been a pattern here in either in multi-touch attribution, in media mix modeling, and in incrementality. Essentially, we're trying to do the same thing. We're trying to see the value of each channel. So you can think of these three concepts as three ways of getting to the same value. Because at the end of the day, we're trying to understand how much is our channel worth. And we should always look at this as a triangle, as a measurement triangle. And if you look at this as a measurement triangle, we'll see that on one side we have media mix modeling, where we are modeling things top down. We only care about either aggregated spend metrics or exposure metrics like impressions or clicks. We are able to join the offline components, and that gives us channel value with that perspective. We don't have the second way of seeing things, which is multi-touch attribution, where we're going bottom up. We're essentially going through, okay, if I can track every touch point of the user journey and I can stitch it up into a coalition or a transition matrix and calculate removal effects, how much is X channel worth? Finally, incrementality, where essentially I do a randomized control trial where to the part of the population I'm going to give ads to that channel and another part I'm not. I'm going to calculate the difference, and that difference is going to be my channel worth. All of these three types of measurements are trying to measure the same thing, but through different lenses. You should never think about them in isolation. It's not that multi-touch attribution is perfect and is useless, or incrementality is overhyped, or media mix modeling will solve everything. All of these approaches are statistical in nature, so they will always have uncertainty attached to them. But if you look at them holistically, we know that they might not give you the same value per channel, because that's the nature of data science methods, but they will be in the same zip codes. So you can use multi-touch attribution and incrementality and media mix modeling to reinforce each other. In fact, for instance, Facebook's best practices says that you should always, the best way to calibrate the media mix model is through experimentation, is through incrementality studies. But if you want to get creative level insights, I want to see specific ad performance, then that level of granularity is really difficult for a media mix model because the data requirements are going to be too large. So then we're probably better with multi-touch attribution or incrementality. So don't consider them alternatives to each other, consider them complements to each other. You're measuring the same thing from different perspectives.